All right, welcome guys. Today we're going to work on significant figures. No one likes significant figures. Everyone would much rather just take their calculator, put all the numbers they get in there, and move on. But they are important, okay? So we really need to make sure that we know the rules and just apply them as we go. If you know these rules, it becomes so much easier to just kind of truck through all of your stuff. So significant figures are important. There are two different types of numbers that we're interested in. Measured numbers versus exact numbers. A measured number is the result of a measurement. Okay, so when you measure something in the lab, whether it's weighing something on the balance, reading a graduated cylinder, taking a reading from some kind of infrared or UV vis, anything like that, those are all measured, right? They're dependent on the person reading them, and they're dependent on the instrument you actually read them from. So anything we measure in lab there is a little bit of room for error, right? Maybe the instrument's off a little bit, maybe it's not calibrated, maybe the student was a little hungover and they not reading it properly. Doesn't really matter. The measured numbers, there is a little wiggle room, and those are the ones that we're really going to be focusing on today. The other type, the exact numbers, they're really well defined. So if you count, right? If I counted, there's one person in this room, just me, right? No one's going to argue that there's only one person in this room, all right? If you count the number of people in your room right now, no one's going to argue with the number of people in the room or the number of days in a year, anything like that. The exact numbers are really well defined. All of our conversion factors are really well defined, and no one's going to argue. So those are exact numbers. The thing about it is, when it comes to exact numbers, we don't really care about them when we're doing calculations. If we run into an exact number, it makes our lives a little bit easier because they're not going to affect our significant figures. So exact versus measured numbers, it's really important to remember the difference. So first of all, how do we count significant figures? We always are interested in the number of non-zeros. The non-zeros is really what triggers everything. Here we have the rules. Non-zeros are always significant. So here's my first non-zero, and we're always going to start with the first non-zero. So there's my first non-zero. 1, 2, 3, 4, 5. I have a total of 5 significant figures. All of the yellow in this slide are going to be considered significant. There are 5 sig figs. We always start with the first non-zero and just kind of roll right through. Any zeros, we're interested pretty much only in zeros, but any zeros between non-zeros are going to be considered significant as well. So 1, 2, 3, 4, 5. There's also 5 in this example. Okay. Next up, the thing called trailing zeros. Whenever you run into zeros that follow a significant figure or a number, those are also going to be considered significant. So 1, 2, 3, 4, 5. There's 5 here. And we don't really care about this zero. It's just before the decimal, before we hit any significant figures. There are 6 on this side. So going back to this one here, why would I write the 20? Why would I write those extra zeros if I didn't need them, right? I could just say 20. It's 20. The answer is 20. Well, no, it's not. It's 20.000. It gives you some level of accuracy, right? It gives you some idea of how accurate that number is, the fact that, wow, there's a lot of zeros on there. Okay, so that is important. That decimal place turns out to be really important. And then finally, the one that really messes people up, and the one that we should only really need to worry about, is the place-holding zeros. In this case, 20,000, that number 2 is the only significant figure. All right, there's one significant figure. These zeros, all they're doing is telling you the size of that 2, right? The magnitude of that 2. It should be in the 10,000 spot. That number, there's only one significant figure. All of these zeros right here, all they're doing is essentially telling you how big that 2 is. The same with a decimal, a really small number, right? All of these zeros, all they're doing is telling you the magnitude of those numbers. How many sig figs do I have? I only have 4. All of these zeros are doing is just essentially giving me an idea of the size of them. It's important to note, though, whenever we do have a decimal, so if I had 20,000, I said that there's one sig fig. If I put a decimal place here, all of a sudden, all of these guys become significant. So now I have 5. So if you look out for that decimal. If you see that decimal is there, essentially, once you run into the number, it's going to, all of those zeros afterwards, all the trailing zeros, turn out to be significant. Okay, so keep that in mind. All right, rules of significant figures. It's going to break down into 2. When doing calculations, when we multiply and divide, we are interested in the number. Okay, the number of sig figs. So here we have a calculation of density, 40.516 grams divided by 21.3 milliliters. the number that I end up with is 1.9, and this is going to come from my calculator. I'm just going to keep writing until I run out of digits. 2159. Of course, I need a unit, grams per milliliter. There we go. We're dividing. I'm interested in the number of sig figs. How many sig figs do I have? 1, 2, 3, 4, 5. I have 5 here. I have 3 here. So how many does my answer have? My answer is limited by the least number of sig figs. So the 3 is what's going to drive my answer. So I need to have, my answer needs 3 sig figs. 1, 2, I'll underline this 0. That's where I should round. When I round, this is the number I end up with. Grams per milliliter. 1.90 grams per milliliter. Easy enough. Multiplying and dividing number of sig figs. Remember that. When we're adding and subtracting, now we're no longer interested in the number of sig figs, but now we're interested in the number of decimal places. Okay, so in this example down here, my number on my calculator turns out to be 37.2214 grams. Okay, now how many decimal places do I have? I have 4 decimal places in this case. How many decimal places do I have? I have 1, right? So 4 decimal places. 1 decimal place. So the least number of decimal places is going to limit my answer. How many decimal places? Just 1. So my answer gets rounded to 1 decimal place. I don't care about the 37. All I care about is the fact that I'm rounding to that 1 decimal spot. So the answer for this becomes 37.2 grams. We are good to go. Okay? These 2 rules are going to drive everything. If you know these 2 rules, you start using them kind of subconsciously as you move through measured numbers calculations. Now, they're not always going to be this simple. All right, we're not going to have just one division or 1 subtraction or 1 multiplication. It gets complicated quickly in lab and elsewhere. So we need to use the order of operations. I'm not going to go through this calculation. I have one example over here. The answer should be 14 when you end up, but you need to follow the order from left to right. It follows the PEMDAS method, right? Parentheses, exponent, multiply, divide, add, subtract. And you always work from left to right if there are multiple operations of the same thing. So if I have multiple exponents, I always do the left one first and then the right. Make sure you know that. If you don't, check Google and look up how to do it. When we run into multiple operations, the ones that really stifle us, we need to be aware of how it works. So here we have a multiple operation. If we look at our example, a percent error. Okay, we're going to follow these simple steps. We're always going to follow the order of operations. So we're always going to be interested in 1 calculation at a time. We are going to use sig fig rules, right? So if we're multiplying and dividing, we're interested in number. If we're adding and subtracting, we're interested in the number of decimal places. We need to use those as we go. And as we go, we're going to underline the one where we would have rounded. Okay, so we're going to always keep track as we proceed. And then finally, at the very end is when we round. So never round until you get to the very last calculation. Never round until the end. Never round until the end. Okay, so here we have my percent error. Let's take a look. So first of all, what am I going to do? According to the PEMDAS, parentheses comes first. I'm going to do this calculation here, first thing. So we have 3.573, and that's in milliliters, divided by, and of course I'm just going to rewrite everything. Now for this, I'm subtracting, so I'm interested in the number of decimal places. 1 decimal place, 3 decimal places, therefore my answer would have had, we're not rounding yet, but would have had 1 decimal place. So I'm going to underline the 5. That's where I would have rounded. Let's just keep track. There we go. Let's do the next operation. We have division and we have multiplication, but we're going to work from left to right, so we'll do the division first. 3.573 divided by 24.527 gives me 0.14567,619 times 100. Okay, once again, just got that from my calculator. Just write all the numbers out. We're not rounding yet. Now, when we divided, remember, now we're interested in the number of sig figs. Well, the bottom number, 24527, this had 5 sig figs. 3.573, well, remember, we would have rounded to that second number, that first place there, the first decimal place. So this would have had 2 sig figs. So where should I round? I need to round to two significant figures. First significant figure and the second. So actually, I would have rounded to that 4. Okay? And then finally, we're going to do our last operation, times 100. Remember, the 100 is an exact number. Okay? It's just turning it into a percent. So we don't have to consider it when we're looking at our sig figs. So this number times 100 gives me 14.567619. And of course, this had 2 sig figs. We would round here, which is going to be my 2 sig figs. It rounds up to 15%. Okay, so there we go. That's how you do it. Make sure that you round appropriately. Make sure you keep track along the way. Underlining is simple enough. Just underline, move to the next one, underline, move to the next one, and then round at the very end. So that's it. I'm going to put these up here. Please post these in the comments below to help others. I'll take a look at some point and comment or root you on if you're getting them right. If you have any other questions, feel free to send me an email. It was on the first slide. Yeah, so good luck, guys. Let me know if you want to see any more videos, and enjoy.